Welcome to Easy Elim, Learning Simplified. My name is Ruth, and today we are going to be learning on the topic structure and bonding. And today is a continuation from the previous lesson when we looked at coordinate and covalent bonds. So for today's lesson, we are going to be looking at the molecular structures and some of the properties, and we are also going to look at some examples. So substances with covalent bonds usually form two types of structures. We have the molecular structures and the giant atomic or giant covalent structures. So for the molecular structures, which is part of our lesson for today, it usually refers to structures in which covalent bonds hold atoms together to form a molecule, and then the molecules are held together by intermolecular forces. So substances with molecular structures are usually gaseous or liquids at room temperature, most of them. A few solids like sulfur, we talked about this in Form 1, iodine, some fats, sugar, naphthalene, paraffin, wax also have molecular structures. And then the intermolecular forces in a molecule are usually in two types. We have the van der Waals forces, we have been discussing them, and we have the hydrogen bonds. So when we start with the van der Waals forces, these are the weakest intermolecular forces because we call them, they're usually induced dipole-dipole attraction between molecules. So if you look at a molecule, for example, this molecule, whatever attraction is between these two molecules is what we refer to as van der Waals forces, and it is an induced force because of the electrons that are always moving around the outermost shells or in the shells. And as the size of the molecule increases, so does the electrons, also leading to the strength of the dipole-dipole interaction increase. So the dipole-dipole interactions become stronger, or the van der Waals forces become stronger as the size of the molecule increases. That is the reason why, like for example, the halogens that we discussed previously, their melting point and boiling point increased down the group. They became bigger down the group. And also the noble gases, their melting point increases down the group. So the strength of the van der Waals forces, as I've said, increases with the size of the molecule. So for example, if you look at iodine, we have the van der Waals forces. This is the iodine molecule, another iodine molecule, another iodine molecule, another iodine molecule. What you notice in between the iodine molecules, the electrons usually attract themselves to the nucleus of another atom using the van der Waals forces. So the van der Waals forces are usually the induced dipole-dipole forces. So that is also another way of seeing it. This is a molecule, 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 molecule. So the bigger the molecule, the stronger the van der Waals forces. And then we have the hydrogen bonds. Hydrogen bonds usually occur in the force between the electropositive hydrogen atom of one molecule and the electronegative atom of another molecule. So it usually causes a formation of a stronger bond that is stronger than the van der Waals forces. And the hydrogen is usually electronegative and it attaches itself to an electronegative atom, preferably like nitrogen, oxygen, and fluorine. These ones are very electronegative. Since it is electropositive, it will attract itself to an electronegative atom. So when you look at water, water actually forms hydrogen bonds. But how does water look like? I discussed this previously in the previous session. So we have the oxygen and bonded to hydrogen. So remember, whenever you see a line, you know it's a pair of electrons. The oxygen attains a partial negativity because it pulls the electron that are being shared closer to itself. So it behaves like it's gaining electrons, so that's why it gains a partial negativity. For the hydrogen, it gains a partial positivity because it looks like it's losing electrons. So you see, this is polarity. There's such charge in the, like, from the word poles. There's a charge at the upper part of the water and charges at the lower part of the water. So when this water can be attracted to another molecule of water of another molecule, so what happens? The hydrogen of one molecule attracts itself to the oxygen of another molecule. The same case happens with oxygen and hydrogen. So this attraction is what we refer to as the hydrogen bond. And this hydrogen bond is usually much, much stronger than the weak van der Waals forces. And this hydrogen bond is the one that disrupts some of the physical properties of molecular substances. And we are going to see like an example of compounds that are of the same molecular mass, but they differ in their melting point and boiling point simply because they have the hydrogen bond and not the weak van der Waals forces. And that example is below. So ethanol is written like that, and ethyl. Ether have the same. If you calculate the relative atomic mass, you find that it's 42. However, the boiling point of ethanol is higher than that of dimethyl ether. So why is it higher? So the reason why the melting point of ethanol is high is because ethanol has hydrogen bond. It forms hydrogen bonds with other ethanol molecules, while the ether does not. So it has instead weak van der Waals forces between the molecules. So this is the answer. So both have molecular structures with covalent bond between atoms, but for ethanol, it has hydrogen bonds which are much stronger and they require more energy to break, while dimethyl ether is bonded by only weak van der Waals forces, which are very weak and do not require a lot of heat. So molecular substances usually are generally insoluble in polar solvents, and but we do have some specific molecular substances that dissolve in polar substance as long as they are polar in nature. So substances that do not dissolve or substances that form hydrogen bond with water is sugar, ethanol, and ethanoic acid. So some properties of molecular structures is, first of all, they have low melting point. They have low melting point because they are bonded by weak van der Waals forces. The molecules are bonded by weak van der Waals forces. And then they are poor conductors of heat and electricity because they do not have delocalized electrons, and also they lack mobile ions. So you need to mention them too because they're the major contributors or the only contributors of electrical conductivity. When it comes to solubility, we said their solubility will be dependent if they are polar or non-polar. So polar substances will always dissolve in polar substances. Non-polar substances, or the ones that do not have the charges, will never dissolve in a polar substance. So polar dissolves polar, and polar dissolves non-polar. So that brings us to the end of the session. I hope you have been able to see some properties. Um, Molecular compounds are usually a bit, you notice in most of the properties is they don't. That is because of their molecular in nature, but now their uniqueness also comes from the separate compounds that form hydrogen bonds with other polar solutions. Those are the ones that create that distinction between molecular substances and ionic compounds. We're going to learn about giant atomic structures in the next lesson, and you notice there are some properties also that are unique with the giant atomic structures that are not with the molecular structures. So I hope you have been able to identify those properties carefully and you can be able to state them with ease. And especially being able to understand what hydrogen bond is and how it forms. So that is important. If not, go back and check out the videos that we have just done. I'll see you in the next lesson.